So electricity and magnetism, block 4, and the dangers of electricity when we are using the electricity. Some cases it might be dangerous to use the electricity. So practical electricity. The uses of electricity, like we use electricity for heating, like electrical heaters we use in our home during winter. That same thing, electric kettles are used to boil the water. It is also used for lightning as well, like boiling. The rice cooker is there. It is also using the heating effect of the current. The lightning circuits for we are using bulbs or lamps. We pass the current, and when we pass the current, these lamps switched on and produce light energy. And we can also use generate the motors are there when we pass the current, like fan or motors. It turn or rotate when we are passing our current. So we can use electricity for different purpose. We can use electricity for heating. We can use electricity for lighting. We can use for motors as well, moving the motors. But when we are using the electricity, there are terms which we can like quantities which we can find. We can work out electrical power. How to calculate the electrical power? It is a current multiplied by voltage, or voltage multiplied by current. So P is equals to VI. And we can also find energy, which is a product of power and time, so which is VIT. So example, an electric cell runs with a voltage of 230 and current 0.4 ampere flow. At what rate of electrical energy means power. So what is the power here? So power is a product of voltage and current, so it will be 230 times 0.4, that is 92 watts. If we need how much energy is transformed in 1 minute, the time should always be in second. Here time is given in minute, so we convert the time into seconds. So power multiplied by time, so power is 92 and the time is 1 minute is 60 seconds, so it is 5520 joules of energy will be used up. Then the cost of electricity, like how we can identify what is the cost, like how much it costs for use of this electricity. So 1 kilowatt hour is labeled as 1 unit of electricity. So how many kilowatt hours, and different countries, they have a different value for this 1 kilowatt hour. Like the price for 1 kilowatt hour is different for different countries. So 1 kilowatt hour is having certain cost. Like example, it can be 3 cent, 0.3 cent. So if 1 kilowatt hour is 0.3 cents, so if we are consuming example 20 kilowatt hour of energy, then how many it costs? It will be X. So we cross multiply and we'll know the cost of electricity. So to get the cost of electricity, we work out by using how much units we consume each, like, or how much kilowatt hour we consume. 1 kilowatt hour refers to 1 unit, and 1 unit is having a cost. And different places, different countries have different costs of the electricity. So we multiply that unit with the cost of 1 unit, we'll get the total bill which is produced. Example, if we have electrical energy cost about $0.9 per unit, like each unit. And what is the meaning of 1 unit? 1 unit means 1 kilowatt hour. 1 kilowatt hour is refers to 1 unit. What is the cost of running an air conditioner when the average power is 200 watt for 8 hours? So first we'll find how much kilowatt hour of energy consumed by the air condition if it is working for 8 hours. So first 2000 watt we divide by 1000, so it will convert into kilowatts. It is 2 kilowatt, and 2 kilowatt 2 kilowatt multiplied by the total time we are running this air or using the air condition for 8 hours, so it will be multiplied by 8. So 2 multiplied by 8, that's equal to 16 kilowatt hour. So 16 kilowatt hour means 16 units are used, because 1 kilowatt hour means 1 unit. So 16 kilowatt hour means 16 units are used, 16 units of electricity. So 16 units of electricity are used, and we know 1 unit If we are using 1 kilowatt hour or 1 unit, it costs $0.9. So if 16 units of electricity are used, how much it costs? X dollars, cross multiply. So 16 multiplied by 0.95. So the total cost of using the air condition for 8 hours, it will cost about $14.4. Same way, an electric heater is there which is having a rating of 3 kilowatt. That's a power. Electrical energy costs 20 cents per kilowatt hour. Like if we use 1 unit, it costs us 20 cents. What is the cost of using the heater for 30 minutes? Whenever we are finding the energy to get the unit, it should always be in kilowatt hour. So energy consumed is power multiplied by time. So power is kilowatt, that is given, but the time here is given in minutes, but we should convert into hour because we want kilowatt hour. So 30 minutes means half hour. So it will be 3 into 0.5, which is equals to 1.5 kilowatt hour. So 1.5 kilowatt hour, it means 1.5 units, because 1 kilowatt hour is equivalent to 1 unit of electricity. So if 1.5 kilowatt hours, it means 1.5 units. And what is the cost of 1 unit? That is 20 cents. So if 1 unit of electricity costs 20 cents, then 1.5 units of electricity will cost X cents. So cross multiply 20 into 1.5, that will give us 30 cents will be the cost of using this electric heater. Is it clear? The two examples, how we can work out the cost of electricity. So when we are using the electricity, we multiply the power and time, we'll get the answer in kilowatt hour. And kilowatt hour means 1 unit of electricity. It's called 1 kilowatt hour. So how many kilowatt hour we consume multiplied by the cost of each unit, we'll get the total bill of electricity. So what are the dangers of using electricity? When we are using electricity, sometimes there might be a damaged insulation, like you are using, say, electrical device for very long time, or the wire might, the insulation might be damaged or cut. This is normally happening for iron, in case of iron. So sometimes the insulation here might be damaged. So if the insulation is damaged, if a person will touch or if a person is exposed to this, he might get an electric shock. So what are the dangers of electricity? Dangers of electricity, number one, that is a damaged insulation. When the insulation, the covering of insulation is removed, then it can cause electric shock. Second thing is overheating. This is very common in our home. We are connecting lot of device to one socket. That is not the right way of using electricity. That will leads to what? Because electricity, use of electricity, whenever we consume electrical energy, it produces heat as well, and that heat can cause a fire. So this is not the right way of using electric. Even when we are using these extensions, that is also a source which might leads to a fire, because from one plug we are using multiple devices. So what is the disadvantage of using devices connected to one socket? Is it produce lot of heat. As a result, when it produce heat, that heat might start a fire or it can cause fire. So overheating of the cable, when too much current we draw from the circuit, it may leads to damage due to heat. It might melt the insulation and then it start the fire. Then damp condition or moist condition, when we use electricity in a damp condition or moist condition, that can also be dangerous. Like example, if your hands are wet, water is not a good conductor, but if your hands are wet or moist and you touch the socket, electrical socket, a small amount of water can conduct electricity, and that may lead to electric shock. So many electrical accidents occur in a damp condition because, like when we have a moist condition, the water can conduct electricity, which leads to electric shock. So dry skin does not conduct electricity as compared to a moist skin. So what are the dangers of electricity when we are using the electricity? Sometime what might happen, we might have a damaged insulation, so we get an electric shock. Sometime we use lot of devices in one socket that cause overheating and that can produce a fire. Sometime in a moist condition, we touch the electrical sockets, it can cause a electric shock. Now, how to make the safe use of electricity in our home? How to make electricity safer for the use? We use a fuse. Maybe you have seen this component. This is called a fuse. What is the advantage of the fuse? Like example, when you are using any appliance, let's say you are using a television. This is the main socket, and on the main socket you have two wires. One is a live, another one is a neutral. Now what you do, you connect the wire, you plug in the television to the socket. So you connect them live. There is another wire which is called earthing, that is optional here. But when we plug in, so one of the wire connected to live wire means the charges are moving, and neutral wire means the charges are not moving. So when we plug in, the charges start to move, transfer the energy from the live wire. And what is the purpose of the neutral wire? It's just to complete a circuit, because inside it will go and then return. So it's just making a circuit complete. So charges start to flow from the live wire, enter the circuit, and then return back to the neutral wire. Now what happened? Example, the television which we are using, it need only 3 ampere. This is what the television need to work efficiently. But suddenly from the live wire, because the current can fluctuate or it change, suddenly from the live wire 5 ampere of current is coming. So this 5 ampere of the current, it is too high, and what it can cause, it can damage the television. This television will be damaged, or its circuit might not work because the current is too high, so it melts the circuit. So it will damage this whole device, the television, and we have to replace the television. So how we can make this, how we can save this device from the high current? So what we do, we connect a fuse here, and fuse is always connected on the live wire. So on the live wire, there's a component which is connected. This is called a fuse. And inside the fuse, there's a metal wire. So we connect a fuse in the live wire, and fuse is having its rating. Every fuse is having its rating. Like if it is if device or a television need 3 ampere, so we can connect a fuse around 3.5 ampere, a bit more than that. Not same, a bit more than that, because it can survive with a smaller change, but not too big, like maybe 15 ampere will come, it will damage. So every fuse is having its own rating. So when the current is too high, like example, fuse rating means this is a fuse which it can allow, like fuse can allow 3.5 ampere to pass. But if the current is 15 ampere, so that current will produce lot of heat and it will melt the fuse. And as a result, when it will melt the fuse will blow. So fuse will break the circuit. So it will protect the television or the appliance. So we just have to replace the fuse rather than replacing a television. And fuse are easy to replace as compared to that of a device appliance such as television. So this is how fuse are protecting the device from damaging. Is it clear, the concept of the fuse and how it protect the device from the damage? Any doubt till this point? So whenever we are using the electrical like components, different components, you will always find we use a fuse. So example, there is an electric fan which is having a rating of 60 watt, 460 watt and voltage 230. What fuse we should plug in? So first we should know how much current is passing. So how to know what is the current passing through the fuse? What is the current needed for this device? So P is equals to VI. P is the power which is 460. V is the voltage 230. Current we don't know. So 230 is multiplied. Other side it will be divided. So 460 divided by, so we need this device, this electrical fan need 2 ampere to work. So if it need 2 ampere to work, so we should use a fuse around 2.5 or 3 ampere, a bit more than that, not exact number, a bit more than that. So fuse rating should be slightly larger than the working current under normal operation. Then we should also use the switches so that we can anytime we can switch on, plug off or switch off or switch on the device. That also make it safe use. Then there are circuit breakers. You have seen these circuit breakers at the main circuit. These are actually the circuit breakers. You will find these circuit breakers, how it work. Circuit breakers are more efficient as compared to fuse, because fuse must be replaced, but circuit breakers we don't have to replace. What happened? Every circuit breaker is having its own rating. Like if I say there's a circuit breaker of 3 ampere and we have the live wire. This is a live wire. Then it is connected to the device like television. Normally circuit breakers are not used for exact the full device. It is used for the whole uh, like house or room, not for individual devices we don't use. But I'm just explaining the idea by taking example of the device. And there's a neutral wire. Now what happened? What is the advantage of using a circuit breaker as compared to the fuse? Say the circuit breaker is on, so it means it allow the current to pass. So current will come from the live wire, passes through the circuit breaker, go into the device and return back, and the device, the television, will work. But your television example required 3 ampere to work, and suddenly what happened? Instead of 3 amperes, suddenly from the live wire, the current exceeded and 10 ampere of the current is coming. So suddenly from the live wire, 10 ampere is coming, but the like a fuse, the circuit breakers are also having a rating. Rating means that maximum amount which they allow to pass. If this circuit breaker is having a rating of 3 ampere, suddenly 10 ampere is coming. So because of this 10 ampere, automatically it will switch off. So it is on, but because the current is too much, it will automatically switch off. As a result, when automatically switch off, it does not allow the current to pass through the device and the device will be safe. Then what we have to do, once the current is normal, we just have to reset or we just have to make it on again. So automatically it will be off when the current is too high, and thus we have to reset and make it on when the current is normal. So advantage of using a circuit breaker over the fuse is circuit breakers, we just have to reset them and they use the magnetic effect of the current, whereas fuse, once the wire inside the fuse melt, we have to replace them. We cannot use the same fuse because the wire is there inside the fuse and that wire melted. So once this wire melts, we have to replace the fuse. But for circuit breaker, the advantage is that once the current is too high, they will be switched off automatically and we just have to reset and make them work again. So circuit breakers are more useful as compared to fuse. And another thing to make the electricity safe, which for avoiding a like to overcome this damage insulation, we should use double insulation. So double insulation means the cable, like example, this is a copper, this is a piece of copper. So we should cover this copper by two insulating layers. Like one is plastic is there, the top. Around it, the first layer is a plastic one. And the second layer so the second layer might be cotton or any other insulating material. So what is the advantage here? This is called a double insulation. So this is a wire, but wire is having two insulators. This is insulator 1 and this one is insulator 2. So two insulating layers around it. Even if one insulating layer is damaged, the other one is there to protect. So it, even one is damaged, the other one is still there. So it will protect us from getting an electric shock. So double insulations are used to protect the person to get an electric shock in case if he touched the wire. Then the last thing, that is about the earthing wire. Normally what happens for devices such as like refrigerators, they have the conducting body like the metallic body. So sometime when we touch the refrigerator, so this is the front, this is a side view of a fridge or a refrigerator. So sometime when we touch the refrigerator, we might get an electric shock. What might be a reason? The reason is when we are using this refrigerator, it is the circuit is there. There's a live wire. It is connected to a live wire and the neutral wire. So one is the live wire, neutral wire, and when we plug in this fridge, so this is a plug. The pins of the plug are made up of conducting material. So when we connect, the current start to flow. It will pass through the live wire and then go inside through the circuit, and then remaining energy will be transferred, making a complete circuit. Now what happened? Sometime the live wire inside might touch the metal body of the device or the appliance. So if this touch the metal body and there's a person, if there's a person and he touch, so if there's a person and he touch this, so what will happen? Because the live wire is in contact with the metal body, and then the current start to flow through the metal body, and it will passes through the person who's touching the metal body, and he will get a electric shock. So how a person can be protected from getting this shock? This because when wires we are using for a long period of a time, so they might be damaged, the wire might be damaged, and that damaged wire might touch the body and the person might get an electric shock. So how we can protect this, how we can protect a person from getting an electric shock? So there's also another wire which is called earthing wire, and instead of using 2 pin plugs we use 3 pin plug. So when we plug in, the third wire is called earthing wire, and that is connected to the earth. So what happened? This earth, when we plug in, so there's another wire which is called earthing wire, which is connected with the metal body and then to the earth. So as a result, what happened? If the live wire is damaged and this live wire is touching the metal body, then the current, because current always flow through the least resistive path, so how the current will flow? The current which enter here will flow back, because earthing is a metal wire, so it will pass through the earth and travel to the, like pass through this, the metal, the earthing wire is connected to the metal body, so it will pass through the earthing wire and then go inside the earth. So this person, when he's touching now, he will not get an electric shock. Why he will not get an electric shock? Because there is an earthing wire which is taking the extra leakage current, we can say, back to the earth. So this is how we protect a person from getting an electric shock. Normally, the earthing wire is used for the devices such as refrigerators, fridge, which are taking, which having a metallic body and taking a large current from the circuit, or taking a large current from the supply. Normally, for mobile chargers, they also provide you a 3 pin, but that third pin is, it's just to fit in the socket. That third pin is made up of a plastic. That is, has nothing to do with the earthing. It is just for plug in the device. It's not working as an earthing, because for mobile phone is not drawing too much current from the circuit. But like laptop chargers, you will find the 3 pin plugs are there, and the third pin is made up of what? It is made up of metal. So because the laptop body, metallic body is there, it can conduct electricity. So when sometime you touch the metallic body, you might get an electric shock. So to remove that extra current, it is connected to an earthing wire. Is it clear, the concept of earthing and the use of the earthing wire? So like you can see here, to make the electricity safe, this is the safest way. We have a switch here, we have a fuse to protect this kettle. So, and we have earthing wire. So when the current will flow through the circuit, it produce heat energy, but maybe there's a live wire touching the metal body, so the current will return from the earthing as well. So if person touch, he will not get an electric shock. You can also identify the type of the wire by using the color. The, the live wires are represented by a brown color wire. The, the neutral wire are represented by the blue, and the earthing wires are represented by yellow and green. This is like a standard which is used to just identify which one is a live. So live wires are having a brown insulation, earthing wires having yellow and green insulation, and the neutral wire is having a blue insulation. So as you can see here, blue is for neutral, brown is for insulation is for earth live, and green insulation is for earthing wire. So we can identify. So what is a live wire? A wire which is connected to a source. What is a neutral wire which complete the circuit, and what is the earthing wire which is connected to a metal body to protect the device from a person to get an electric shock. Is it clear the dangers of electricity and how we can make it safe, the use of electricity? Any doubt related to this topic, the practical electric circuits?